Hello everyone. Today we will discuss about graph isomorphism. So what is isomorphism? Isomorphism is a Greek word and is derived from two words. One is iso, other is morphism. So what is iso and what is morphism? Okay. So iso means equal and morphism means to save or to form. So what is isomorphism in graphs? So that means this is graph isomorphism. That means two graphs having same shapes or same structures. Okay. So for example, taking two graphs, this is graph G1 and this is graph G2. In graph G1 there are four vertices A, B, C, D and one edge E1, E2, E3, E4, E5. 5 edges and 4 vertices in graph G1. Similarly, in graph G2 there are also 4 vertices and 5 edges. That is, the vertex sets are A1, B1, C1, D1. Okay, and the edge sets are F1, F2, F3, F4, F5. Okay. So these two graphs are isomorphism graphs, isomorphic graphs, and these two graphs have different structures and number of vertices are equal in two graphs and number of edges are equal, but the corresponding vertices and corresponding edges are equal. So corresponding there are 1-to-1 correspondence with the vertex sets and 1-to-1 correspondence with the edge sets. So here A is corresponding with B1, B is corresponding with C1 and C is corresponding with D1 and D is corresponding with A1. Similarly, we can check the pair of vertices. Now taking the pair of vertices is AB and the edge is E1. Similarly, A is corresponding with B1 and B is corresponding with C1. So AB joined with edge E1 and here B1 and C1 is joined with F2 in graph G2. Similarly, B is corresponding with C1 and D1 is corresponding with C. There is also an edge E2, here also an edge F3. Okay. Next, C. Come to the vertex C. C is corresponding with D1 and D is corresponding with A1. Here also an edge E3 and here also an edge E4. Now, B is corresponding with A1 and D is corresponding with C1. There is also an edge E5 and here also the edge F5. So there is 1-to-1 correspondence of all the vertex sets and the pair of edge sets. So from this example we conclude that the definition of graph isomorphism, that is a graph G1 is order pair of V1 and E1 is said to be isomorphic to the graph G2 with the order pair of V2 and E2 if there is a 1-to-1 correspondence between the vertex set V1 and E1, V2 and a 1-to-1 correspondence between the edge set E1 and E2 in such a way that if E1 is an edge with the vertices U1 and V1 in G1, then the corresponding edge E2, here edge E1 is correspondence with E2. E2 in the graph G2 has its endpoints, the vertices U2 and V2 in G2, which correspond to E1 and V1 respectively. So this pair of correspondence is called graph isomorphism. So taking another example. Taking another example, this is a complete bipartite graph. It has 6 vertices and we can take the vertex sets are A, B, C, D, E, F. And the edges joined with A is joined with D, E and F. B is joined with an edge D, E, F and C is joined with edges D, E, F. So this is a complete graph and we can take another graph. This is a irregular graph. It has 6 vertices also, and this is a 3 regular graph. And these vertex sets are A1, B1, C1, D1, E1, F1. Okay, these two graphs are isomorphic graphs because there are same number of vertices and same number of edges, and the corresponding vertices and edges are equal, 1-to-1. There are also 1-to-1 correspondence with the vertices and with the edges. So the two graphs are isomorphic graphs. Similarly, we can take any two graphs and comparing the correspondence of pair of vertices and edges, we can check the isomorphism of the graphs. Okay, taking some more examples, graph isomorphism or graph isomorphic examples. So first example is these two graphs are isomorphic graphs. Okay, so there are number of vertices are 4, here also number of vertices are 4 and number of edges is 5, and here also number of edges are 5, and we can correspondence with V1 is correspondence with W1, and V2 is correspondence with W2, V3 is correspondence with W3, V4 is correspondence with W4. Similarly, we can correspondence edge E1 with F1, edge E2 with F2, edge E3 with F3, edge E4 with the edge F4, and E5, edge E5 correspondence with edge F5. So, correspondence of edges and vertices, we conclude that these two graphs are isomorphic graphs. Similarly, you can check these pairs are isomorphic graphs. So, you can check it and enjoy the isomorphism. Okay, thank you.